Hi everyone, this is Mrs. G, and today we're going to do a review of absolute value functions. But first, please pause the video and give this warm-up a try. All right, so just like we did with our constant and linear functions, when we're learning about a new family of function, we're going to start with our parent function. So for absolute value, it's just y equals absolute value of x. So if you plug in these x values, you get these y values, and here's what our parent function looks like. So absolute value functions are functions that have an algebraic expression with an absolute value symbol. And remember, the job of an absolute value symbol is to make the value of whatever's on the inside positive. So these graphs are very distinct. They're made up of two linear pieces. So the graphs are made up of straight lines, but it's not a singular straight line, and they come to a point. So they're V-shaped graphs. Now, the domain of our absolute value functions should always be all real numbers, so negative infinity to infinity. But our range, you can see, is restricted. Our lowest y value is 0, and our highest y value would be infinity. Now, key features, they come to a point, and that point right here is called the vertex. And for our parent function, the vertex is at the origin. Now, of course, that can change depending on the equation, but that's kind of our starting point. So our parent function has the vertex at the origin, and then the slope for when x is greater than 0 is positive 1, and the slope for when x is less than 0 is negative 1. So you could see to the right of my vertex, my slope is positive 1. I go up 1 over 1, up 1 over 1. But to the left of my vertex, my slope is negative 1. I go down 1 over 1. So on this half of my graph, my slope is negative 1. And you can see that the slopes are going to be opposites. So first we're going to review how to graph an absolute value function. So this is kind of the general form of our absolute value equations. So sometimes you'll see a constant being multiplied in front. We'll call that the a value. So a times the absolute value of x minus h, and then plus k. So when it's in this form, we're always going to start by looking for the vertex, which can be found at hk. Now you'll notice in this form that it says minus h, and here it says positive h. That's purposeful. So whatever you see in your equation inside the absolute value, the opposite of that is going to be the x value of the vertex. Now for the k value, you'll notice this says plus k, and this is a positive k. So this number will always be the same, but this number will be opposite. So that's the one tricky thing to remember. So once you know the vertex of your function, we're going to take this a value, which is whatever value is out front, and that's going to be the slope of your function to the right of the vertex, and then the opposite of that a value is going to be the slope of your function to the left. And then from there, we know that it just makes straight lines. Each half of your absolute value function is linear. So then from there, you just connect the dots in a straight line. All right, let's give some of these a try together. So we're always going to start by stating the vertex. Now here, I don't see anything added or subtracted to x, so my h value is 0. I also don't see anything added or subtracted on the outside, so my y value is also 0, which means my vertex is at the origin. Now since my a value out front is negative 2, that's going to be the slope of my graph going to the right of my vertex. So from my vertex, I'm going to go down to right 1, down to right 1, down to right 1. That's the right half of my graph. So again, we'll see that the slope is negative 2. But on the other half of my graph, the slope should be positive 2. So we're essentially going to do the same thing, but in the opposite direction. So we're going to go down to left 1, down to left 1. And then we'll connect those to make a straight line on the left. So you can see that this half of our graph has a slope of positive 2. So we have that V-shaped graph, except this time because of that negative out front, our graph is facing down. All right, let's look at part B together. So for the vertex, remember this value should always be opposite. So here I see x minus 1, but the x value of my vertex is actually positive 1. The k value is the same. So if this is a minus 4, this should be negative 4. So I'm going to start with that. So 1, negative 4. And then I look for my a value. So when you don't see a number out front, it means that that a value is just positive 1. So I start at my vertex, and going to the right, my graph has a slope of 1, which means I go up 1, right 1, up 1, right 1, like this. And then on the left of my vertex, I'll do the opposite slope. So up 1, left 1, like this. So we still have that V-shaped graph, and each half of my graph has opposite slopes. Here my slope is 1, here my slope is negative 1. All right, let's try this next one together. So here, I don't see anything added or subtracted to x, so that means my h value is 0, but I can see that this plus 2 is added on the outside, which will be the y value of my vertex. So 0, 2. And my a value, we can see, is 2 over 3. So from my vertex, I go up 2, right 3, up 2, right 3, and I'll do the opposite going to the left. Up 2, left 3, up 2, left 3. So again, the slope to the right of my vertex is 2 over 3. The slope to the left of my vertex is negative 2 over 3. And this last one, for the vertex, I see x plus 3. Remember, it's always opposite for that h value, so negative 3. And then I don't see anything added or subtracted after, so it's going to be negative 3, 0. And then I can see that my a value is just negative 1. So from my vertex, I go down 1, right 1, down 1, right 1. And then I'm going to do the opposite of that to the left. Down 1, left 1. And that creates those opposite slopes, which creates that V-shaped graph. So again, on the right side, my slope is negative 1, and on the left side, my slope is positive 1. So there you go. If you know how to interpret that form of our absolute value functions, these are super quick and easy to graph. Remember, just identifying the vertex, and then the a value is your slope going to the right. All right, go ahead and pause the video and give these a try on your own. All right, go ahead and check your work here. Make sure you have the correct vertex for each graph, and then the correct slopes going to the right and the left. All right, so now we're going to review how to solve an absolute value equation. So when you're solving an absolute value equation, the first thing you're going to try to do is to isolate your absolute value term. So I can start by adding 2 to both sides. So 3 times the absolute value of x plus 4 equals 15. Then I can divide both sides by 3. And once I've isolated my absolute value term, I'm actually going to set up 2 separate equations. The absolute values are essentially taking what was inside and making sure it's positive. So since the result is positive 12, it actually means that one of the answers could be negative 12 and one could be positive 12, but the absolute value made them both positive. So once you've isolated, you're going to lose the absolute values, and you're just going to set one side equal to positive of whatever that constant is, and one side equal to the negative of that constant. So we have 2 separate equations, one that is for the positive answer that remained positive, and one that was for the negative answer that the absolute values made positive. So here I'm just going to finish solving for x. So x equals 8, and x equals negative 16. So these types of equations, it's super, super common to have 2 answers, but You could also have one solution, and it's also possible to have no solution. All right, let's give this next one a try. So again, my goal is to isolate this absolute value expression first. So I'm going to subtract 6, and that's going to leave that negative attached. And then I'm going to divide both sides by -1. And this is where I make my two separate equations. One will be equal to +8, and one will be equal to -8. And then I just need to finish solving for x. And here again, I get two valid answers to this equation. All right, let's try another one together. So here, I'm going to isolate my absolute value again. So we have, I'm going to add 2 to both sides. So -4 times the absolute value of x plus 2 equals 8. Then I'm going to divide both sides by -4. So the absolute value of x plus 2 equals -2. Now here you have to recognize something. An absolute value expression should always be positive, right? Whatever's on the inside, these absolute values should make that result positive. So if you ever see an absolute value expression equal to a negative number that you see here, this is a case where we have no solution. So you really just have to recognize that from that point. Again, an absolute value expression should always equal a positive number. That's the whole job of an absolute value, is to make your result positive. All right, go ahead and pause the video and give these two a try on your own. All right, go ahead and check your work here. So here I've isolated my absolute value expression, and then I set 1 equal to +1 and 1 equal to -1 to get my two solutions. And for part B, when I isolated the absolute value of x plus 3, it was equal to a negative value, so this is no solution. All right, so now we're going to practice solving absolute values inequalities. So we're going to do this in two different ways. We're going to do it graphically and then algebraically. So when we're doing it graphically, we're going to graph the left and the right sides of the inequality separately. And then we're going to highlight everything above if the absolute value is greater than, and everything below if the absolute value is less than. And then if it's greater than or equal to, we'll include the points of intersection, and if it's just greater than, we won't. Now, again, for these types of problems, we're going to get a variety of answers, just like with our equations. Your answer might be a single interval. It might be squished between two numbers. But your answer could also be two completely separate intervals. It could also be no solution, and it could be all real numbers. So there's 4 options for what you could get here. And again, first we're going to do this graphically, and then we'll do it algebraically. All right, let's give this first one a try. So here I'm going to treat this like its own equation, and I'm going to treat this like its own equation. So the left side of my graph is just an absolute value function. We just reviewed how to graph this. The vertex should be at -2, 2. So right here. And the slope going to the right should be +1, which means the slope to the left is -1. And then we're going to graph the line y = 6, which is a constant function, which we reviewed last lesson, and we know that that makes just a horizontal line at y = 6. Now, when you're solving graphically, it is really important that your graphs are super accurate. So please take your time, use a straight edge if necessary, but your graphs need to be accurate. So we could see that we have points of intersection here and here, but I don't want to know where they're equal. I want to know where my absolute value function is above or equal to. Remember, greater than means above. So where is my blue function above or equal to my red function? So I can see that that's happening in two separate intervals, here and here. That's where my absolute value graph is above or equal to my constant graph. So let's describe those. This interval, I'm describing the x values where this exists. So this would be negative infinity up until this x value, right? And if you look at this x value, 1, 2, 3, 4, 5, 6, it's at negative 6. So we have negative infinity to negative 6, which is going to be inclusive because of the or equal to. And then since we have a second interval, I'm going to use my union symbol for or, and then I want to describe all of these x values. So this x value is 2, and it's all the x values to the right of 2. So that would be 2 to infinity. And there you go. So I have two separate intervals for my solution. All right, let's try another one together. So in blue, I'm going to graph this absolute value function, which has a vertex at +1, +3, and I can see that the slope to the right of my vertex is -2. So I go down to right 1, and I do the opposite to the left of my vertex. And I get my nice V-shaped graph. And then I'm going to graph the constant function y equals 1. So again, I am looking for where my absolute value function is greater than my constant function, meaning above it. But this time you can see that that's happening in just a single interval, in just this area. So here I'm just going to have this answer squished in between these two x values, which would be between 0 and 2. So 0 to 2. This one is non-inclusive because it's just greater than and not greater than or equal to. All right, so now we're going to review how to solve absolute value inequalities algebraically. So just like when we're solving an equation, we start by isolating. And we're going to create two separate inequalities, just like when we were solving the equations. We do one for the positive case and one for the negative case. Now, when you do the negative case, you have to remember to flip the inequality symbol because it's like you multiplied or divide by -1, which again flips the inequality symbol. Now, the tricky thing about these problems is to decide if your answer should be two separate intervals or that interval squished in between. And that's going to depend on how your inequality is set up. So if after you've isolated your inequality or your absolute value, it says that the absolute value is greater than becomes an or problem. So this or that, meaning you're going to have two separate intervals. And if your absolute value is less than, it becomes and, meaning it's squished in between. So if you have an or problem, or means you don't need to have overlap in your answers, right? But if you have an and problem, for those less thans, you do need to have overlap. So I always say greater is or, less than is and or does not require overlap, but and does. All right, let's give one of these a try. So first thing you need to do is isolate. So the absolute value of x plus 5 is less than 12. Now, before I do anything else, as soon as I've isolated my absolute value, I'm going to write either the word and or. And remember, less than is and. So this is going to be an and problem. So I'm going to write it, box it so I don't forget. So now I'm going to create my two separate inequalities. One for the positive case, so x plus 5 is less than positive 12, and then x plus 5 is greater than negative 12. So notice that I made it negative and I flipped my symbol. Don't forget to flip it because it's like you're multiplying by -1. Now, since it's an and problem, I know that I'm going to need overlap in these two answers. So I'm going to finish solving. So I have x is less than 7 and x is greater than negative 17. Okay, so I want to help you visualize this by putting this on a number line. We want the overlap of these two expressions. So for this, here's negative 17, and here's 7. So it's everything that's greater than negative 17 and less than 7. So we could see that the overlap in those two would be all of the numbers between negative 17 and 7. So if I want to write this in inequality notation, it looks like this. If I want to write this in interval notation, it looks like this. So remember, we need the word and then we have to look for the overlap of my two answers. It has to be both this and this. So it's really important that once you've isolated, you determine what type of inequality problem this is. All right, let's do another one together. Now be careful, if you judge this problem too soon, you're actually going to get it wrong. So we have to isolate before we decide if it's and or. Now in this case, to isolate, I'm going to divide both sides by negative 2. So this side becomes positive 3, but remember, if you multiply or divide by a negative, your inequality symbol needs to flip. So this is actually a greater than problem, and remember, greater means or. So this is going to be this or that, which means you don't need overlap in your intervals. So here I'm still going to set up my two separate inequalities, one for positive 3, one for negative 3, and I need to flip the symbol, flip it and make it negative, and then I can finish solving. X is greater than or equal to 6, or x is less than or equal to 0. So if you visualize what this is, here's 0, here's 6. It's numbers that are less than or equal to 0, or greater than or equal to 6. So for this, because it's an or problem, you do not need overlap. So if you're writing this in inequality notation, your answer actually needs to have the word or in it. It needs to say this or that. And if you're writing this in interval notation, it'd be negative infinity to 0. And sorry, 0 is inclusive, so I do a bracket. And then I do my union symbol for or. And then I do 6 to infinity, and 6 is inclusive. So remember, if it's this or that, you don't have to have overlap in your interval. So you oftentimes will just end up with two separate intervals. Or maybe you'll get all real numbers if they cross over and if they cover every single number. All right, here's the last two you try, so please pause the video and give them a shot. All right, go ahead and check your work here. So part A, once you isolate, we can see this is an or problem. So you get x is greater than 2 or x is less than negative 4. Don't forget to flip your inequality symbol when you make the negative one. And you can see that there's no overlap in these anyways, so you have two separate intervals. And then once you isolate your second one, remember in this step, from here to here, you're dividing by a negative, so your inequality symbol flips. Less than is and. So I have x is less than or equal to 1 and x is greater than or equal to negative 1. So if you graph this to see where the overlap is, you can see the overlap is between and including negative 1 and 1. So here I have this using both notations. All right, that is all for today's video. Thank you so much for watching.